Hello and welcome to another one of D's ADD videos. Today we're going to be looking at using Laplace transforms to solve higher order differential equations. Consider a higher order differential equation of this basic format where A, B, and C are constants. You can solve this differential equation by using the Laplace transform of a derivative in the following manner. If you want to take the Laplace transform of any y to the n where it's some level of the derivative, whether second, third, whatever derivative, it'll equal s to the n, so whatever your derivative is, if it's the third derivative, s exponent would be 3, times y. The capital Y always stays y, minus s to the n minus 1 times y is 0. This will be replaced with a number that's given, minus however many you got to get to s to the first power, and then y to the n minus 2 of 0, finally ending up with y to the n minus 1 of 0. These will all be numerical values. Okay. Now that's kind of odd if you've never seen them before. Let me just show you the main ones you'll be dealing with. Write these down because you'll be using this. So these are going to be your main players. For the second derivative, it's going to be s squared y. Again, this capital Y stays y always. That's what you're going to be solving for. Some books use y of s, but since your variable is s as well, that gets confusing. Just do y, I think is better. And then minus s, y of 0, minus y prime of 0. Note that the second derivative ends on the y prime. The first derivative ends on just y of 0 and no derivative, just the y. Okay, so just see that pattern. If you memorize these three, you should be good. So in this scenario, this big y right here stays y, all the other y's are plugged in. The third derivative ends on the second derivative initial condition. Okay, it goes 3, 2, 1 for s powers. So let's look at the steps. You're going to take the Laplace transform on both sides. For the left side, you're going to use these rules we just went over. Okay, and you're going to include the a, b, and c, plug in the y double prime, the y prime, and the y using these guys. Then simplify everything on the left side. On the right side, you're going to use your table and do the Laplace transform. So hopefully you have a version of this accessible to you at all times. You will get really familiar with the common ones the more and more you do these problems. But for the right side, you can use this table. Then you're going to solve for the capital Y that was not attached to a 0 in your transformed equation. And bring everything else to the other side. Then divide, factor out the y, and divide. And then you'll have to do partial fractions to simplify and decompose the fraction into simpler terms. The reason why is because our tables that we use on Laplace transforms don't have any, if you see, all of these are pretty simple fractions. Right? So we have to get it to look something like these guys down here. So then you can do the inverse Laplace. Hopefully you've already seen that video in practice, those examples, and then you're done. All right, so check out the example video of solving equations using Laplace transforms. You should have enough to get you started at least. Practice, practice, practice is always the key to improving your game, whatever game you're playing. So whether it's basketball, differential equations, or golf, whatever it is, you need to practice. Thank you and have a nice day.